up, everyone? Welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank easy rated algorithm, beautiful triplets. So what are we provided? What are we looking for? What is a triplet? Well, we are provided an array, and a triplet is any three numbers that have an equal difference between them. So 2, 3, and 4 all have an equal difference between them of 1. There's a difference between 2 and 3 of 1 and a difference between 3 and 4 of 1. So basically you take the midpoint and you see how far it is from the two other ones, and if those are equal, that means you have a triplet. In this question, you're provided an array of numbers, and you are to find the number of triplets between all of the numbers. And so this example, the first example, shows that we wouldn't evaluate these two twos as one integer of 2. There would be two separate triplets for the two separate twos, the 2 at index 0 and the 2 at index 1. You wind up getting, I believe, 3 triplets from this. Yeah, 3 triplets here. Index value of 0, 2, and 3 is your first triplet. Index values of 1, 2, and 3 is your second triplet, and index values of 2, 3, and 4 are your third triplet. So let's go ahead and head over to Replit and start to get to work. Okay, so let's do we need that? I don't think we need that. Okay, what we do need is counters. One way to go about this, let's delete this, we don't need that. I'll walk through what that is a little bit later. I'm actually going to go over 2 different ways to solve this question. First one's a little bit more of a hard-coded method, a more traditional method. Second one, you can use a function that you can import from collections. But so we're first going to do the old school way, make sure we're understanding everything before we wind up doing the second one. Okay, what should we do first? Well, we know we're going to need to store the triplets for all of the triplets that we find. So let's just go ahead and set a triplets variable equal to 0, and as we find triplets, we will increase the number of the triplets variable. I bounced around a couple different ideas on how to do this question, and I wound up creating a counter. And what a counter is should be clear once I write it out. But I'll just go ahead and create the counter first and then describe what it is. I used R here, and I set R equals max of array plus 1. Okay, let's not run that. Let's print our counter and then run that. Okay, so that should give us an array of how many zeros? An array of 6 zeros. So what we just did here is we created an array of 6 zeros. And the reason we did this is because each of these index values will represent the actual integer as it appears in our array. And what I mean by that is we can then take a loop and do for num in array counter. Oh, I'm frozen. Okay, there we go. Counter num plus equals 1. And then we'll go ahead and print our counter again. And this will show what this counter array is and how it's operating. And you should never make typos. Okay. So that should give us our counter array. Great, updated with the occurrences of each variables. And what's happening here? So this first index position represents the integer of 0. When we loop through our array here, the first number will be 2, right? So we're going to go to index position 2 and increase that. This shows that we have 2 2s in our array. This shows that we have 1 3, 1 4, and 1 5 in our array. We have no zeros and we have no 1s. Basically, the index position corresponds to the integer itself, and then it shows us how many times that occurs in our array. So there you go. Now we've got a number array with the occurrences of each integer in our array. Now what can we do? Well, we can loop through our array, and we can say if oh, I never went over D. D is the desired difference between the numbers in our array to create the triplet. So even if there was a triplet like 2, 3, and 4, you would think that would be a triplet. But if our D was 3, it would not be, because 2 plus 3 is 5, not 3. The difference is important. And the desired difference in this example is 1. Okay, so why was that relevant? That was relevant because we can evaluate if there are existing possible tuplet numbers. So the first number we'll evaluate is 2. And we can write a conditional statement that says if in our array 2 plus 1 exist, if at index 3 the value is not equal to 0, we have a potential tuplet. That means we have a 2 and we have a 3. And then we also add the conditional statement, and if index 4 exists, if 2 plus D exists, you've got index 4 here. If that is not equal to 0, and we have all 3 of those, that means we have a triplet. So let's write out that conditional statement. It's not too complicated, and we will use an I loop to find the actual position in our counter array, or in our actual array first. Okay, so let's do for I in range. Let's go ahead and hard code n. In Hackerrank, you don't need to hard code n. It's just provided, but n is really just the length of r, of the array. Yeah, I guess r and r is confusing, the length of the array. Okay, so we go back to range, and what would the range be? Well, we don't need to evaluate these last two numbers, because as we're walking through our array, we will get up to 3, and then we will evaluate these last two numbers. So for I, we can actually just walk up to this index position, which is n. We can write that as n minus 2. And so there's our for loop. And then what should we do? We need an if statement, right? And it's going to be two separate if statements. It's if r of I plus d and r of I plus 2 times d. But what are we looking for? Where are we looking for this value? We're looking for it in the counter. So if that value, if our counter, what does this mean? So I of 0 plus I of 0 is equal to 0, right? What is array of I of 0 plus 1? That is 1. It's index 1. What's our value here? It's 0. That means we have 0 ones. Doesn't really matter. Oh no, I'm sorry, I did that completely wrong. What is r of I? R of I is 0. That means the value is equal to 2. And then we go into our counter and we check to see if there is a possible middle tuplet value, which would be 2 plus 1. Is there anything that exists at 2 plus 1? Yes, there is. At our third index position, we have a 1. So if that is not equal to 0, it means we have a tuplet. And then again, here, counter bracket, I want to close this in our bracket too, and also bang equals 0. And why is it not equal to? Why is it the bang equals as opposed to anything else? Well, all we need to do is check to see if it exists. It doesn't matter how many there are, we just need one. We need at least one to show that it exists. And then what would we do if we meet this criteria? Well, we would take triplet and we would triplets actually, and we'd plus equals 1, and then we would go ahead and print. Let's print our triplets here. Wow, I cannot spell today. Triplets. Okay, let's give that a try, and we should. Oh, interesting. We didn't run into an error. There actually is another layer that we need to add here. And it's best exemplified by switching up to this array here. Let's copy and paste that over. Great, and I believe the D is 3 here. Let's double check. Yeah, D is 3 here. Okay, so let's run this, and I believe we run into an error. So what's happening here? Well, when we get to I of 3, what is the value at I of 3 here? It is 5. And what are we looking for when we have the value of 5? Well, we are looking to see if the counter has the value of 8, because what's D? D is 3. We're adding 3 to 5. We're checking to see if there's an 8, which there is, and then what else are we checking? We're checking 3 more than that. We're checking for an 11, which is out of our range. So if we can fix this by moving this down, moving it over 1, and adding a conditional statement here. And how would we write the conditional? We would write if R of I is less than or equal to the max of the array minus 2 times D. And what is that saying? I think, do we need some parentheses? No, we should be good without any parentheses. Okay, so what is that saying? That is saying that we should only evaluate numbers up to this number. And what is this number? Well, in this instance, what is the max of the array? The max of the array is 10, meaning that 10 would be the last triplet value. So what is 10 minus D? 10 minus D is 7. And then what is 7 minus D? 7 minus D is 4. That means that 4 is the highest first triplet value we can have. Because if you go to 5, that means that the second possible triplet value of 11 is outside of our array, and it automatically could not be a triplet. So by adding this conditional statement, we're only going to go through our loop up to that number, or we're going to keep looping. Technically, you would do all the loops, but you would only manipulate, you'd only have the possibility of manipulating the triplets variable if you met that condition first. So let's go ahead and try to run this again, and there you go. It solves our issue. We wind up with 3 triplets. Let's go ahead and copy and paste this over into Hackerrank. Let's copy and paste it correctly. Move everything up a bit. Our loop there is good. Our loop here, not quite. Bring you back here. Change this to return. Okay, and let's get rid of that print, and let's get rid of that print, and this should pass. There you go. It passes our sample test cases, and it should also pass all of our test cases. It takes a little while. The runtime on this problem is a bit slow. You've got multiple conditionals, multiple fors. It's not the fastest thing in the world, and that is why I will show you the next possible answer. So there you go. You pass all the sample test cases, but let's go back to Replit and utilize something called counter. Do from collections import counter, and this actually comes from Ashwin over at Hackers Realm, I believe. I am not a huge fan of ever importing anything and using it. That would just mean you'd have to know a lot of different, you'd have to memorize a lot of different things, and when you're actually interviewing, that's not really a skill that they're looking for. They're looking for more problem solving. But nonetheless, this is a great answer and something you may utilize in your career, so I figured it'd be something worth covering. So what does counter do? Well, counter does something pretty powerful. Let's set a variable of m equal to counter array. And let's print that. Print m. From collections, is that it? Let's try that out. Okay, there we go. It builds out a dictionary for us that keeps track of all the occurrences of each integer in our array. 1 occurs once, 2 occurs once, 4 occurs once, 5 occurs once, 7 occurs once, 8 occurs once, 10 occurs once. And then you can write a really simple conditional where you'd write if m of, we need to write a for loop. Let's write a for num in array. If m of num plus d and m of num plus d times 2. All that's saying is if these exist, we will take a triplet, set that equal to 0, and then here we will increase the triplet by 1 each time we satisfy those conditions. And then we will print our triplet. So you can see that this is a much more simple way to write the code, but like I said, it involves remembering that this counter function exists and then going ahead and importing it, and just not exactly the best look on an interview, but super powerful and super simple nonetheless. So let's just quickly walk through what's happening here. We are looping through our array and evaluating each number in our array and saying, we're checking our dictionary. Does the value of our number plus d exist in our counter? And do both of these exist? Does the middle triplet as well as the last triplet exist? If yes, then we will increase our triplet by 1. And that's it. Nice and simple. I hope you trust me and believe that if you pop this into Hackerrank, it's going to pass. I'm not going to do that right now. You could also check out Ashwin's video at Hacker's Realm and see that they pass on his end. But that's it. Thanks for watching. I hope this is clear. If you have any questions at all, please feel free to drop them down in the comments below. If you like this video, please go ahead and hit the like button. And if you're at a point in your life, your career, where you are covering algorithms, definitely go ahead and hit subscribe. We cover algorithms just about every day. So thanks so much for watching, and hope to see you in the next one.